I gave this talk in Sydney, and actually I gave it as a second talk when I did it in Sydney a couple of weeks ago. And I was very frustrated because the talk that went before me was a guy named Graham Lee from Tyro Payments, and he did this fantastic, really practical talk about their experiences and what they were doing with microservices, and basically stole all my thunder. So I thought, it's fine, it's not going to stop me. I'll bring it to Melbourne and just smash it there. And then I come to Melbourne Microservices, and thank you very much, at Smart Hall, for basically doing my talk before me, better than me. So, with that said, microservices. Reference architecture. The reason I like to use this term reference architecture is because I spend 80% of my time at clients building real reference architectures, actually ones that they're going to use. And when you're doing that, a lot of time you're making decisions, but every decision you make you have to justify. Reams of documentation, meetings, decisions by committee, no fun at all. So the beauty of being able to get up here today is that I can just say, this is the answer with no justification required whatsoever, which is just very, very refreshing. So this is not just a reference architecture, it's an opinionated straw man reference architecture. I will make no attempt at justification. You're welcome to disagree with me, you're welcome to agree. Just don't hold me to anything that's said here. What I'm really trying to do is give an idea of what you need to consider for microservices from start to beginning. So Dave did a great talk that was focused heavily sort of on the infrastructure management side of things. I'll touch on that a little bit, as well as what's needed from the design side also. I mentioned it, it's about 80% of my time I'm doing this. I know you're all wondering, what do you do for the other 20% of your time, Yamen? Well, what I do is I look for a font where the mu, right, is both the Greek symbol for micro and the letter M. And you know, you're not going to just stumble across that. You've got to really look. So I think I found it. And the reason I bring it up, other than to show how mildly insane I am, is that micro is a very interesting word. I think there's a lot of focus with microservices around micro meaning small, but I think it's probably better focus to say micro means lightweight. So think microgram instead of micrometer. We're talking about lightweight services. And the reason that's important is that you have to consider how lightweight you want a service to be, because the alternative to microservices and sort of this containerless approach is big app servers and containers. And they give you a lot. So it's always worth thinking about what you've given up and what you need and what you don't. What should be trimmed away and what shouldn't. Martin Fowler did a blog post not too long ago saying the prerequisites if you want to do a microservices reference architecture. Who's read that? It's a fairly popular one. And he talks about some good stuff. He says you have to be, this tool to ride on the microservices roller coaster. Provisioning, monitoring, app deployment are the main ones. And those three are very important. But I think, you need quite a little bit more than that. The important thing to understand with microservices is it's a trade-off. You're trading code complexity for operational complexity. It's going to be a little bit easier to get your head around each microservice, but they're not in isolation. It's going to be harder to get your head around the infrastructure and the system of systems as a whole. So I created an acronym. When you consider microservices, if it's right for you or not, the important thing to consider is the proportion. Is what you have to add to make microservices a reality going to be worth what you get out of it? I'll talk a lot today about what you need to add to actually make it possible. So supporting infrastructure needed as a proportion of the thing, or Sinpot with my Afro devil, because the devil would have an afro, because why not? Worst diagram ever? Acronym. I don't know. What's it? All right. So I noticed there was the Sam Newman's Microservices book floating around here earlier. He likes to sort of show the picture of microservices as these hexagons, these honeycombs, which is really cool because they just fit so nicely together. The problem with that is that they fit so nicely together. It makes it seem like you build these services and all of a sudden they just plug in and they're this harmonious thing. It's so easy to change. But this fitting together just cleanly, everything working perfectly, that's not an attribute of microservices. That is actually an attribute of monoliths. I mean, monoliths have a lot of problems, but they don't have any of the ones related to distributed systems. They don't have any issues with regards to service discovery or latency, network lag, partial failure modes, any of that stuff. Compile time dependencies, type checking if you use the same language. You get a lot for free with monoliths. I know we like to rag about them, but trade-off, right? So this is the microservices landscape, and to get them to gel together, you need some weird grey lines. And this talk is about the weird grey lines, which was going to be my other title, but unlikely to have been as popular. All right. Well, let's talk about lines of code with microservices. I'm going to talk about my 3 lines of code. No, my 3 levels of conviction. The reason I bring this up is because, again, this is opinionated. When you're providing an opinionated talk, I think it's always good to give people a bit of an idea of how opinionated are you. Are you just saying this because you need to have an answer to something, or do you really believe it? So I have 3 levels of conviction. The first level of conviction is Jerry. It's just a little bit take it or leave it. I'm giving an opinion because there's an opinion to be given, but I'm not going to be defending it to the death. The second level of conviction is Kramer. I'm fairly passionate about the things that have Kramer attached to them. There's other options, no right or wrong, but I will get into an argument if I need to. The final level of conviction is George. Everyone knows it's coming, right? I should just put Elaine there just to throw people off. This is stuff that I think is just that. There's some things you shouldn't be doing, there's some things you must be doing, and you'll see George attached to all those. Now, who can tell me what that is? Box. I'm glad no one said a crappy picture. It's a box. It's a box. It's a black box. Yeah, have you not seen the dress picture? This is a black box. So it's a black box. This is how we sort of view microservices. A microservice written in kind of any language. We don't care what happens on the inside. And I think this is a lot of what we this is a lot of how we view microservices. They are this thing that exposes an interface or something, and we don't care what they're in with. We don't care the language. We don't care the runtime. There's no container or anything like that. It's a very idealistic view of service, just caring about the contract, because we focus very much when we say that on the interface contract of the sort of core functionality of the service. There's a lot of stuff that needs to go around that to make a service manageable, monitorable, deployable, and to work well in an ecosystem of other services. So, this talk is about what goes on the outside of that black box. It's true we don't care what's on the inside. What sits on the outside of that box to make it somewhat homogeneous with all the other black boxes that are running around. And now I start with the proclamations. So 1, use Docker. Just use it. Docker really does create a fantastic environment where you get a lot of what you want out of microservices, which is not caring about runtimes, being able to use different languages, caring less about the implementation detail, and having something lightweight and portable without having 100 different things in your production environment. You've got one thing. You've got Docker containers. And the beauty about Docker containers is there's only 2 types of Docker container, literally. There's a stateless Docker container and there's a stateful Docker container, and that's it. As far as managing Docker containers are concerned, you only need to know the difference between these 2. So again, with the last talk, I believe you guys just had stateless containers, which are managed in one way, and you can focus on managing them. And if you have stateful containers, you have to manage them slightly differently because the data needs to move with the container, needs to be managed with it, and so on. There's ways to do it, but fundamentally, once you've settled on Docker, you can treat every microservice as one of these 2 things in all your tooling and all your build processes, which is really strong. I'll even go as far as to say that even databases are microservices. You can Dockerize databases, you can Dockerize Cassandra nodes, Elasticsearch nodes, and so on. And the reason that's powerful is because it means you only have these two things again. So in your environment, pretty much everything can become Dockerized. It's one unit of management and monitoring. There's OSs, there's a lot of like Docker specialty OSs being released right now. I think, Rancher, Core OS and so on. Even Red Hat has released Atomic Host, where everything other than the initial sort of boot service, every other service in the system is Dockerized. So forget about the functional stuff. Absolutely everything, the thing that runs cron is Dockerized inside that operating system. So don't limit yourself to thinking of microservices as these little RESTful web applications. They are everything, including databases. All right, number 2, configure using the environment. So when you start using Docker as a container, you pre-bake your application image. So the bits on the image layers in Docker become immutable, and that is what you use as your unit of deployment everywhere. So the big question becomes, how do you configure those containers? Because they all look the same in all the environments. So how do you, when you go between environments, apply configuration? So there's a lot of ways to do it. The pattern that we've been using, I've been using pretty successfully, is make each container, each microservice depend on one thing only, and that's environment variables. Because then you can say, here's my microservice, and here's the list of environment variables required to configure it, and that's actually all you need at that point to make that completely portable. Why environment variables? Because they're ubiquitous, they're easy to understand, and they're easy to manage with a lot of just general admin tooling. How does it then work? So because what's on disk in the Docker container doesn't change as you move between environments, and you've got these environment variables, you're going to have processes that can't be configured at runtime by an environment variable. We all have a lot of systems that need to be configured from the file system and properties files and configuration scripts and so on. So what we do is, with the Docker container, you have a template configuration file and a startup script that takes the environment, substitutes it into the template configuration files, and then starts the process. So almost all your applications end up being an application with templated configuration and a dependency just on environment variables. So start up, configure the service based on the environment, and then start the service. So this is a really good way to do it. I know there's a lot of other ways. There's toolings that make this, that take this sort of approach and make it more standardized. But always start low tech. You can roll this at home pretty easily. And this sort of matches the 12-factor app way of looking at the world. Rely on the environment, gives you maximum portability. Now, how do you create those template files? And how do you substitute environment variables into them? I'm a bit Jerry on this. Doesn't matter. There's a lot of ways to do it. You can use Shell and just use sed. You can use Go with Go templates, Python, Ruby. It honestly doesn't matter. Whatever your team is comfortable with, as long as the dependency is simply on that environment. Now, if you're in the scenario where this is fine for sort of start up and get a configuration, sometimes you're in an environment where the configuration changes dynamically based on what's happening in your microservices landscape. So in that scenario, there's a bit more of a, impetus to use something like Consul. So who's heard of Consul? I think there was a talk in Microservices Melbourne on Consul. So for the purposes of this slide, Consul is the distributed key value store with a RESTful API. So you can store your configuration in there. And you can update configuration into there. Thank you. The cool thing about Consul is this thing called Consul template, which if you run that inside your microservices, so I talked about the startup script earlier, that sort of reads the environment variables, substitutes them into properties, then starts up the process. If instead you use Consul template to be that startup script, what it can do is it can read the configuration from Consul instead of the environment, substitute it into the properties file, same as before, but then it can also, and start the service, then it can also watch Consul. So it puts a long pole onto Consul and watches for those environment variables to change. And it does it cleverly. So if there's a change, you can ask it to wait 5 or 10 seconds so that all other changes get propagated before it does its job. When it sees a change, it can update the configuration file again and then restart or reload, cause the service to reload its configuration. Very cool, pretty advanced, only use it when you need to. A lot of times this is considered for service discovery type stuff. When the topology changes, I need to reload my configuration. There's better ways to do that stuff. So sidecar processes like a local HA proxy are one. Using Consul DNS, which I'll go into later, is another. So it's not necessarily for service discovery in that kind of dynamic config, but there may be other scenarios. Like dynamic log tracing, putting it up and putting it down and so on. Okay, so number 3. George comes out for the first time. Centralise your logs because, when you've got these distributed systems and you want to know what's going on, what do you not do? You don't SSH and then tail -F into every machine. Go, oh no, it's not running on this one. I started on this one, now I move to this one. And believe me, when you first do this, that's what you'll do. And for ages you go, oh, my life sucks. And then you'll realise, oh, there's an answer to this. If only I'd gone to that Microservices meetup. So Logstash and the LK stack, I think a lot of people put their hand up earlier. You know about it. There's a lot of ways to do this. I like the solution that was proposed earlier in terms of using syslog. We kind of go low tech because in a lot of our environments, there's not that many machines in the cluster. So we get our microservices to write to a log file, which almost never blocks. And then we get Logstash to pick up from those local log files and send it off to an Elasticsearch cluster. The problem with that approach is if it's a lot of, non-homogeneous services, should be a name for non-homogeneous, the Logstash configuration for those files kind of has to move around with the service. So it's not suitable for very complex environments to do it to file, but it works in a lot of cases. So this is kind of a low-tech way to get centralized logging, and it's very cheap, 0 cost. So this is, just for the record, this is probably not how you would actually deploy something like this. The beauty of Logstash and the way it all comes together is that that's how you deploy it if you had two microservices, one Logstash container put into a cluster. If you have hundreds of them, you can chain Logstash into a topology to achieve some sort of high availability and reliability. But doing this is not enough. What you need to do is enable distributed tracing. So it's fine to say I'm centralizing my logs, but what I really want to do is be able to trace a call that's going between microservices and trace the sort of history of that call, where it initiated, its parents and so on, as it moves across the systems. So I don't want just centralized logging. I want a way of connecting all those logs together when I'm looking at a particular issue or a particular problem. And sometimes you want to do that based on technical correlation identifiers. Sometimes you want to do it based on business identifiers. This is where you apply a lot of thinking up front as to what you're going to want to search on and get it into those logs early. General rule of thumb is log everything and then start taking things away. Now, that all sounds good, and I'll admit we've done this plenty of times in the past. Usually the naive way of doing this is to add a correlation identifier in the origination, sort of the first call that comes into the stack, and then pass that identifier on as it goes through all the calls. The problem with that is a call that is actually like that and distributed across a number of services is actually a hierarchy. And if you log it with a single correlation identifier, when you get the logs, you get something flat. Which is okay as soon as but then falls over when you want to start doing things like dependency analysis, performance management, and try to isolate bottlenecks and so on. So what you really want to be able to achieve is that your logging needs to be able to understand hierarchy of calls so you can rebuild a structure that looks more like that. There's a number of ways to do it. Google wrote a paper called Dapper where they describe a way to do it that'll kind of work for all synchronous distributed calls. They did an open source implementation. Twitter wrote an implementation called Zipkin, which is open source and in Scala, and you can sort of have a look at it. You kind of have to dig into Scala code to see how they implement it. But it's not rocket science. It's just as you hop between calls, you don't just identify the overall transaction you're part of, you identify the parent, the child, and so and then you can rebuild something like that. So very cool, very important. There is, at the moment, in the open source community, no good language neutral way to do this because it's something that you need to instrument inside client libraries as opposed to something you can just apply at the service level. So there's a lot of good client libraries that help you out in the JVM world. I'm sure there is in other languages as well. But there's nothing at the moment that's kind of infrastructure level that'll do this. You have to get it into your code or it is an aspect to your code. All right. George says standardise monitoring. So other than logging, that's one side of it. Monitoring is the other side. You absolutely have to have. And you want to have this standardised because monitoring is actually really easy and really hard. It's really easy because once you set out to do it, it's not that hard to do. It's really hard because it almost never comes out of the box. There's almost always something you have to do to enable monitoring. Either choose a framework, choose a tool, or write something into your services to enable them to be monitored. And monitoring is more than just, am I up, am I down? Because that's only going to help you solve a small proportion of any issues you might get. It's what are my statistics and how am I actually operating? So look, I'm going to provide a simple pattern for this. This is one that we use, but again, this is just one way of doing it. Because we want to be language agnostic about it, we expose a /stats endpoint on all our containers. It returns a standardized JSON structure showing you both health and statistics. And then we run a collect D on each host. So if you're talking about scheduling, you'd run one of these per host. It uses the Docker daemon to discover all the Docker containers running on that host, polls them for their stats periodically every few seconds, and sends it out to an external monitoring tool. Lots of ways to do it. This is one. External monitoring tool is good because a lot of the open source and internal monitoring tools tend to require infrastructure that's fairly extensive, which also requires monitoring, and you get this sort of Russian doll scenario, which kind of like the crontab one. Now, the cool thing about this is there's sort of a meta pattern in all of this, which is that on each Docker host, when you standardize on Docker, there's a thing called the Docker daemon, which knows about all the Docker containers running on that host. And any Docker container running on that host can also talk to the Docker daemon and find out about other Docker containers, which means you can have dedicated containers inside hosts whose job is to know about the other containers on that host and do things with them. So the collect D container here is also a Docker runtime, but it's looking at the local Docker daemon, doing a periodic poll, getting the JSON structure, looking at each of those endpoints, and then monitoring that particular container. So it's a really, really cool pattern to let you build things that, the beauty of this is that we can build this once. This is the collect D Docker agent, and now we can use it anywhere because all it depends on is Docker. It doesn't depend on any other intrinsic aspect of the other containers. Docker, and that they have stats endpoints. And the containers that are being monitored, what we get them to do is we get them to expose environment variables, or they're set up with environment variables that define how they should be monitored. So do they have stats enabled? Should they be monitored at all? What is the stats port that they're exposing on? What's the stats URI? I mean, you can use whatever you want here in the environment variables. What you're trying to do is signal Docker and the Docker daemon on that host to know about your container and how it should be monitored. So you as a microservice aren't dependent on the monitoring. It comes, finds you, monitors you, and sends it out. It's a cool pattern. Okay. Enable events. So this is the, whenever we talk about microservices, it's always this concept of services, sort of feeling that everything's request response. The jewel of services is events, and in my opinion, I think you can get a very robust microservices architecture beyond a certain scale without having the concept of events as a first-class citizen. Because distributed systems without any sort of, that are fully synchronous, are ripe for failure. Again, it's a proclamation. You can challenge me on this later, but I have the microphone right now. So with events, there's a number of things you have to enable for an event-driven oriented architecture to work. And one of them is the piece of infrastructure that all the events flow on. So use Kafka. Who here knows about Kafka? who has used Kafka? Anyone? No. It's pretty new technology, but it's unbelievably cool. I can't talk about this for very long because I become like that guy, green like the Hulk. Kafka is who's used message queues? Is a better question. Okay. Message queues have a really cool paradigm. Drop something, fire and forget. Someone else can pick it up later. It can be durable, be persistent. But it's very much a queuing paradigm. I'm targeting someone or even a topic, and they'll come and pick up that message. And when they pick up that message, it's gone. Or if they weren't there listening to it at the time that it was sent out, it's gone. So it's very much this idea of delivering a message, more like mail. Deliver the mail, pick it up later. Deliver the mail, everyone reads it, and it's gone within a few seconds. Kafka has a very, very different view of that same problem. It says view event streams not as discrete posted messages to queues, but rather as this distributed log. So anyone who's familiar with sort of how database replication works will know that you have a database and you make a write to it. The way that database will replicate to other databases, or even internally, before it processes it, is it writes that particular action to a transaction log, which is a log. I mean, as you know, as a log, a time series ordered set of events on disk. It writes it to a log, and that log is what's transmitted and used by downstream systems. Because it's a very, very straightforward sort of construct. It's immutable, it's ordered, and actually, it's very, very easy to distribute if you do it properly. So Kafka allows you to treat the things that happen in your system, events, as if it was a log file to a degree, and have that distributed and used by a whole bunch of other systems who can call onto it and retrieve data from that log, or who can just be listening passively to it and receive events as they happen. The thing that sort of sets it apart is that there's just one version of the log. Messages expire from it after a certain time period, and you can use it therefore, that one log for as many consumers as you want, for batch processing as well as real-time processing. Very, very cool. Okay. The harder part about events is how do you, what goes into an event? Events are one of those things, again, that seems really straightforward. Yeah, let's just use events. And you go, okay, what should we throw into an event when it happens? There's usually three ways you kind of define an event structure. Either the event contains the snapshot of the entity. Let's say the event is customer updated. The event might contain the whole new customer record. Anyone downstream just picks up that record and works out what they need to do with it. Customer updated, here's the whole record. Or the event can contain a reference to the customer. It just says customer 1234 updated. And you can call back if you want to find out more, or you can just treat it as customer updated. I just need to know the fact that it updated. I don't need to do anything with it. So leave it to the consumer to call back and work things out. Or you can do sort of the delta approach, which is that you say what's changed in the event. You say this field, and this field has changed in this customer update, and provide a reference for callback. Or you do sort of a combination of all those. Like there's a lot of ways to do it. There's no right way in terms of how you model events. It really, really depends on the domain and how you expect to use them. I know we've kind of done all of those in the past, and while we might have preferences for one versus the other, they're very context dependent. But the really important thing about events is that you should be modeling these domain events as part of service design. So define services, don't forget to model the events. Model the events from day one, and all of a sudden your units of composition that you have when you're working with other services are far richer. It's more than just services and events. It's one of those things that's kind of, it's hard to realize the power of until you've really done it for yourself. Okay, services. So this is what people really talk about when talking about microservices, things talking to other things. There's still a lot of stuff you have to consider when defining services. Transports, formats, serialization, availability, reliability, discovery, and so on. So I'm going to go through a few of those. Firstly, protocol-wise, just use HTTP. There's a lot of lightweight messaging and other protocols that can be used for services to talk to other services. And if you're the unique snowflake, you may need one of those, but for the rest of us, HTTP is going to be perfectly fine. It's ubiquitous. Everyone has a client, their browser, and their command line, and it fulfills the vast majority of request response requirements. So unless you have a good reason to think that you're going to be different, regardless of what your parents told you, just use HTTP. But never go full REST. Because, I think people get kind of religious about how they're using HTTP, and they forget the context of what they're trying to do. It's gotten to the point where there's actually a REST maturity model out there. And the problem with maturity models is it suggests that the more mature you are, the better it is. I think it might be better to be called the REST evolution model, perhaps. Dinosaurs evolved, and they were the best thing around at the time in that context. And we've evolved, and we're the best things around, well, the Sydney-siders are, in our context. It's not about maturity, it's about the context of the environment that you're in as to what level of REST you need. So I'm not having a dig at hypermedia. Hypermedia can be cool, but certainly religious fervour around is this RESTful or not. It makes for good blog posts and it's fun after a few beers, but it has no position in the workplace. All right. Have a data format standard identified. I don't care which one. Just do something, because if everyone's defining services in a different way, it's not going to be helpful once there's 30, 40, 50 of these things. So just pick one. There's a lot of really cool standards out there. JSON API is pretty good for defining JSON web services. XML schemas, I know they're not cool, they're not going to get you the chicks, but they work. Pick one or two and just stick with it. You've got the data format worked out. You have to be able to specify your service itself. So you need a spec and ideally a portal for the service. So if you get the data format, the payloads, you need something for the service. It says this URI with this HTTP verb, and these query parameters will return this kind of result, and these are the error conditions, and so on. There's a couple of good ones out there. Swagger, API Blueprint, RAML is the one we tend to like, mostly because it's YAML. Just pick one. And then if you have a spec, you should be building documentation from that spec so developers can go there and use it. If you have a spec, you can build a whole bunch of other things like client libraries as well. But at the very least, a portal and a spec go hand in hand. All right, controversial one. So service discovery is such a pain in the ass. But there are really simple solutions that just involve 8 moving parts to solve it. Your microservice can be deployed anywhere and they can be running on any port. So if only there was a way where I could just give it the name of the microservice and it told me where it was running. If only someone had invented that technology. So DNS is really the perfect protocol to use for service discovery. The problem with DNS is, it was invented like in 1848. And no one knows how to update DNS files. So Consul, which we were referring to earlier as a name value store for configuration, can also be used as a service discovery tool. So certain name value pairs in Consul, the one that sort of says this service name is this IP, if you put them in there in the right way, Consul actually has a DNS server that will respond to that name with that IP. That's sort of for a request. And then you can do service requests where it will tell you not just the IP, but also the port. That's all well and good. That solves the lookup side of the problem, but how do you register your services in there and keep them maintained? And herein lies the power of Docker. So just like we had collect D earlier, sort of running on each container, looking at the local Docker daemon, discovering things, and then looking at the monitoring those. Registrator, which I think, Saul, you've already spoken about at one of the meetups? Yeah. So Registrator runs in a similar way. It runs on all the Docker hosts. It's a Docker daemon as well, container as well. It looks at the Docker daemon and it finds out what services are running there, and then it registers them. And when they stop, it deregisters them, and when they start up again, it re-registers them. So, the step there is pretty straightforward. Registrator discovers all your services and it registers them. They're now available for DNS lookup, which is the thing that happens anyway whenever you call a service, and then they're called. So this part of the process, 3 and 4, becomes much easier. And if you use Docker, step 1 and 2, straightforward as well. So very, very nice ecosystem there. as long as you just use all of this together. There are all alternatives. So HA proxy sort of running as a sidecar locally on each daemon is a really, really cool one. This works for non-HTTP services really well. I guess HA proxy does too. The issue with this is it works really well for name lookups. So give it a host name, get an IP. Service lookups, you kind of need to use client libraries that understand how to do service lookups. So who's done a DNS service lookup? Right. So this is a bad idea. Ideally, we talk about client libraries in a second. That's all going to be handled for you. Talk about client libraries now, actually. I think this is pretty controversial because client libraries are kind of falling out of favour. We were talking about the protocol and use HTTP and use JSON and have a spec and so on. But you don't need any of that if you give your consumers a client library. You literally don't need any of that. It's just an internal call for them. So why would you care about all those other things? You do all that so that clients who you don't know about in future can come and interact with your service, and that your service is well behaving at the infrastructure level. You still need all these things to debug and so on. But client libraries, as a way of shortcutting the use of your service by the clients, actually fantastic. It's really, really hard to call remote services well. If you ask all your clients to call remote services well independently, they're all going to do it badly. Stuff like retries and back off and circuit breakers, stuff like versioning and trying to make sure the client can handle backwards compatible changes, and things like working out the right serialization of deserialization libraries. All of those are not simple things to solve. So invariably you're going to have a whole set of standards to how to solve them, or you can take your spec and produce client libraries that solve everything for you and are plugged into your service discovery mechanism and so on. So Twitter sort of has Finagle as their kind of the ubiquitous client library and actually server library as well. Netflix has a whole bunch of stuff that are client libraries that plugs in there. But I think the point I'm trying to make is there's all these frameworks that help you, but don't leave it to the client, the one using your service, to define those. As part of publishing a service, if you can, ideally automatically, publish a jar or a gem or an NPM module that lets someone else use that service, then the kinds of issues you have in production and during testing are significantly reduced. Alternatively, you can use consumer-driven contracts. The interesting thing about client libraries and consumer-driven contracts is they are also in this kind of tension. They're both trying to solve the same problem. Consumer-driven contracts is saying, hey, ask all your consumers what they expect of this service and then test against that whenever you develop your service so that you don't break any consumers, which is a really cool idea. With client libraries, you've told all the consumers how they're going to use your service. You've embedded that into some code. So all you need to make sure you can do is be backwards compatible with previously released versions of your client libraries. So look, I think there are two approaches, and there's a fair bit of controversy. I don't think you need to do both of them. Usually it's sufficient to do one or the other. Depends on your environment. Okay, next, use continuous delivery. I don't think I need to talk a lot about this. When you have a lot of moving parts, the last thing you want to do is manage them manually because that's just going to cause them to break. Inevitably, something will go wrong if you're doing things manually. The cool thing is that Docker makes life much simpler here. So the real strength of Docker comes out when it comes to moving the containers and doing things with them. So this is an example from one of our production environments where the gold, yellow writing is what is specific to what's inside the container. Basically how you build the little internal package. So that might be a Go build thingy-majig. It could be a make file. In our case, it's Maven. Feel sorry for us. So that changes a little bit in a couple of the stages. Everything else, Docker tagging, building, pushing, pulling, running, is the same. So you get to a point very, very quickly in your continuous delivery cycle where you can scale. If someone says, I'd love to use this new technology, a really big source of friction when you come to use new technology is how am I going to put that technology into all this tooling that we already have around continuous delivery and monitoring and so on. So by standardizing on what the outside of the box looks like, which is Docker, you remove a lot of that friction. So once you've got Docker in and you're doing continuous delivery, you should also then use Docker Orchestration. So this is where Mesos, Marathon, Kronos, and so on fit in. I mean, there's so many others. Kubernetes, Centurion, Helios, Clocker, Flocker, and the name goes on. Saul said earlier, it's like a Cambrian explosion of these tools. And what will happen, I'm sure this year, is that they will start to consolidate and merge, and the mature ones will come out, and there'll be some best practices developing in this area because it's absolutely exploding. But what it's really saying is that I want to be able to take a container. Fundamentally, what you want to do is take a container, and I want to be able to say to something, this container should run X times on these kinds of machines. It should be restarted if it fails. It should depend on these other containers. It should move with its data or be stateless. And just give it a set of attributes and have something manage where it fits and moving it and restarting it and so on. It's roughly the problem you're trying to solve. And you want it to work both on your laptop and in the production environment. And we're getting really close to what sounds like magic there. There's a lot of really, really cool technologies out there about this, and I think this would be a really worthwhile talk if someone wanted to deep dive into one, like really deep dive into one that they've been using. So use Docker Orchestration. So in the end, that's what your black box really looks like. Your handles for moving things around continuous delivery, services, events coming in and trickling out. It's all tested and QA'd, it's monitored, logs are flowing everywhere, and now you have a real microservice, everything you need around it. And then you get a lot of these things and put them onto a delivery tool chain and have them just rolling into production all the time. And this big crane moving around and slotting them in, and they're all just fitting in perfectly together in this like bleak communist landscape. But at least you've done microservices now. That's all I got, guys. Any questions? Yes.
So the communication between microservices with service discovery.
Yep.
How do you authenticate to those microservices?
It's a whole different thing. So security is like security is outside of this. I tend to treat security as an inside-the-box concern as opposed to an outside-the-box concern. So it might be good, depending on your environment, to sort of standardise on how security is done. But for the most part, you've got HTTP. There's heaps of layers you can put inside that to allow you to apply security. Not so much part of the service discovery mechanism. I should be able to discover a service even if I can't call it. Controversial? All right.
This is a problem I have, the service discovery versus configuration management. It's like, where do you put which bits? So with that service discovery, with that configuration management, to say, I'm looking for this service and here are the tokens to talk to that service with.
Oh, yeah.
It's like, where does that all go?
So Consul, which is what I'm suggesting for service discovery, I wouldn't put config management like tokens and so on there. So Consul has ACLs. You can limit when you talk to Consul, not at the DNS level, not at the service discovery level, but when you talk to it at the key value level, you have to authenticate yourself, and that limits what data you can get. So configuration items can be in Consul and be locked down, or make configuration management a whole different thing. There might be more static configuration management like Chef, Puppet, and so on. But I think it's probably prudent to keep discovery of the service and use of the service as two different concerns. And if that means different infrastructure, what's that? Like DNS is, exactly, like DNS is. This DNS and the service discovery really want to try to make it an infrastructure level concern as opposed to anything higher than that. More portable that way. But, just my opinion.
But wouldn't it have to be kept in sync for this service? Here's my credentials. Because if you're doing A/B testing or you're going to a completely different service, it might be a DNS lookup, but that service you're looking up could change, and that could be a completely different set of credentials for that service.
Yes, that would be a problem. Yeah, so that's not solved at the general level.
I haven't seen anything on security.
Yeah, but I would suggest that, let's say you had that scenario where you had A, B services and you knew you were going to run them like that, right? There's part of you has to consider, or part of the solution has to consider they always have two services that I want to call, and I would move my security credentials alongside the name of the service. So here's service A. I'm calling service A today, or A1, and here's my credentials. configuration management tells me I'm now calling service A2, and here's my credentials. But that's not anything to do with where is service A1 and where is service A2. That's a different concern.
So that would be the key value store or console name or something.
That's right, it could be that, absolutely. Or it could be in Git with your configuration management and lockdown repo. It could be however you manage that kind of credential. But one's telling you which name to use, the other one's saying, now that I have a name, where is that service, which is infrastructure level. Anyone else?
Service discovery, right? And protocols, you mentioned use HTTP, right? Unless you're a special snowflake.
Yeah, unless you're a special unicorn.
Maybe, so, and service discovery and HTTP, right? So HTTP is a tricky bit. You need load balancers.
Yep.
If you want to have load balancers in front of every
Yep.
logical service, you have a load balancer. What's your opinion on using messaging for, so just instead of looking for a service, find the nearest messaging server?
Absolutely. So I mean, the alternative to HTTP is messaging. Like it's kind of as simple as that, right? Yeah. We've done both, and they're both good. The reason I like HTTP is ubiquitous. It's just so much easier to understand. And so if you've made service discovery easy, if you've solved that problem, because the big issue with HTTP is, you have to know the final IP at some point, or some intermediary has to know. If you've solved that part of the problem, then a lot of the issues with HTTP disappear. And so if you've solved that, HTTP is a better answer because of its ubiquitousness. It's just so easy to use, so easy to debug, so easy to understand. If you don't want to solve any of those and you've already got a messaging infrastructure, because that needs infrastructure too, right? Yeah. If you've already got messaging infrastructure, then that might make sense. So I think neither is free. They both need infrastructure.
I guess the interesting thing there, if you look at the way Consul works, it uses HTTP as the last mile, if you like. So Consul distributes where the services are and who's the leader and who's the followers, etc. It does all that back-end stuff using its own RPC gossip protocol. But the agents, if I'm a service or I'm a client, I'm looking for a service, I'll use HTTP to a local Consul agent to discover the information I need. So that's the ubiquitous last mile. But for the
or DNS.
Or DNS.
Or DNS, yeah.
So yeah, DNS and HTTP is the last mile. The heavy lifting, eventual consistency, all protocols, etc. They're all RPC or messaging type protocols in the background.
Yeah. I think it'd be really, really cool if there was a ubiquitous messaging protocol that everyone sort of had access to on the command line. Like, HTTP or DNS, because it does make a massive difference, especially as you go through development and testing and so on, to have everyone be able to call a service without client libraries and tooling and so on. Massive difference. So trade-off, but I would these days lean towards HTTP, I think, because these other tools solve the flip side of the problem. Yes, sorry.
Okay. How big should you be for this reference architecture actually start to give you value? Even when Daniel was talking, I think even that was teetering. I'm like, it's a lot of cool stuff.
Yeah.
But it seems to be a lot of overhead just to get 4 or 5 services going.
We're one sysadmin and 2 developers.
Yeah.
So
with 12 machines.
Yeah, so I think actually that brings up a good point. I think there's a lot of parts, but how much effort do they require to manage? There may be 2 different things. But even having a lot of moving parts can sometimes mean, issues in identifying what's wrong. I don't think there's a correct answer as to how big you have to be. It's a proportionality thing. So, everyone gets SymPod out there as an acronym.
So the one thing that worries me is people are talking about, we should go towards microservices and stuff. And then everyone's like, but there's too many moving parts to manage a lot of this stuff. That's exactly what you're building. As long as you make sure that each part has its own domain, then you know where to look when there's a problem. And you shouldn't be afraid of spinning out a dozen different things in order to get one task done.
Absolutely. I think the friction comes into the fact where if you say, if I'm just going to deploy this one WAR into this application server, I just get so much for free. Yeah. And all those things are not free with microservices. You have to go and build them. Exactly. So I agree. It's not so much the operational issue. It's that you just have to build all those things so that there is no operational issue. If you try to run a microservices environment without doing monitoring and centralized logging and all the other fun stuff we've spoken about today, it's going to be a massive headache. So you need to be able to invest in doing all that. How long that takes you, actually it's shrinking a lot day by day because frameworks give you a lot of it for free. So I think the hump to get over in order to do microservices is probably shrinking because you're going to get a lot of stuff out of the box, out of the black box. There you go. Anyone else? Yes.
More of a question about Kafka and
Yeah.
that method. So you're saying use HTTP is kind of ubiquitous?
For services.
Okay, right.
For services. So I think services and events are kind of, I treat them differently. So this whole section was services, use HTTP, service discovery and so on. Kafka is its own thing. It's proprietary. And most asynchronous ways of communication that actually scale and work well are proprietary. I mean, they're open source and so on, but they are not an established standard. AMQP is probably the only one that's actually a standard. And it is an alternative. So both RabbitMQ and ActiveMQ have AMQP. I mean, RabbitMQ is just AMQP. But you can use them at that level. Kafka's a better model. It's worth a talk in and of itself, in all honesty. And really have a deep dive into it because you're going to see it everywhere in the coming year, I think. Does that answer your question? I know I sort of jumped in early.
Yeah, it does. I was just more curious about, probably more about how Kafka works and some things like, obviously if you have a centralized bus with infrastructure around, making sure that's fault tolerant, redundant, all that sort of stuff. But it doesn't have like a local outbox type.
Yeah, so to go really quickly on how Kafka works, it needs a zookeeper cluster, so it already gives you an idea of the kind of infrastructure you need underneath it, right? Step one, zookeeper, yeah. And actually in the documentation it says, so just find your local zookeeper cluster, like you have one hanging around. That part of that might go, but you're kind of talking at least a minimum of 3 nodes, and the log is actually a distributed log. It's partitioned based on a partition key, and each partition sits on the number of replicas you want it to sit on, and consumers talk to those replicas, and each consumer has its position in that queue, which is also distributed and replicated. So it's kind of, under the covers, it's much more complicated than that one central thing. Unlike these guys, these scale terribly because they're not distributed by design. They're centralized by design, and they try to achieve high availability of some way. Kafka is distributed by design in the sense that no SQL databases are. So it makes a lot of trade-offs, and there's limited what you can do with it, but as long as you fit within those use cases, it's far more powerful in terms of distribution and performance. It's about 10 times performant as the other systems.
Would you recommend using it as your distributed data store instead of a database?
You can. It's just limited in terms of its query capability. So in Kafka, you can, the way sort of the protocol works is you tell it where you want to start. So you can start at the latest, you can start at the earliest, and it will just give you the stream of events. And then as new ones come in, it will give you new ones if that's what you want. But I can't query it. I can't say, give me this event. It's not a database. It's a log. So it's very good because it's a log, because it knows its predictable access pattern, it's predictable how it's going to store it on disk. It's why it's so fast and lightweight. But it can't be used as a general event store. That would need to be something listening off Kafka as a microservice that's storing all the events and is available for query. Different thing. Can be used for event sourcing, absolutely, as long as your access pattern is always going to be. So there's a lot of good hooks from Kafka into various event sourcing libraries and frameworks, but you just need to be reading it sequentially. That's all. You can't query it, is the point. You can say start here and just give me all the events. Okay, well that's me. Thanks, guys.